Well, first of all, thank you, James. Thank you, everyone. It is wonderful to be here. And what I'm going to talk about is an idea, a concept that came out of a book I wrote on 20th century science, something I was trying to cover a lot of ground. And it's an idea that I thought pulled together, made sense of quite a lot of science in the 20th century. And it's about problems, generation of problems, and I guess the promises come in when we think about how are those problems solved. What I'm going to do is tell you a bit about that idea and then talk about how I think it relates to promises, because very much in the context of thinking about this paper, the more I thought about it, it's a lot to be said about promises and science. And I think it is, as James said, a very promising subject for a workshop. And I also want, if I have time, I want to tell you a little bit about some of the most recent research I've been doing, which is much more contemporary, which I think adds and extends the concept that I'll be starting with. But let me start with a little story just to get us in the right place. Imagine it's night, and like many of us, we've just got on an aeroplane, we've taken off, and what we look and we see out our window is something like this. It is a sublime sight. It is a pattern of bright lights, which is very impressive. It's an extraordinary sight. Then the flight continues, and then several hours later we're descending into a new city. This time it's not at night, it's at dawn. And what we see now when we approach the city is something quite different. It is, we see the streets, we see the factories, we see people going to work. And that pattern of lights, which before was just an extraordinary image but made little sense, now makes sense in terms of patterns of work. So this is a little story that I think helps us into ways of thinking about the sciences in the 20th century. Because our first sight of the sciences in the 20th century are of essentially a series of very bright spots. Things like the invention of new physical theories like quantum mechanics, or the detonation of an atomic bomb, or the Human Genome Project. Isolated, bright moments that you get in sort of timeline histories of science, which in themselves don't make sense. But when you start to see them as part of a wider world, a wider working world, I think you begin to make sense of how those sciences fit into wider patterns of history. And this led me, this introduces an idea, a concept that I call working worlds. Now, working worlds are arenas of human projects that generate problems. And I think that sciences solve the problems of working worlds, but also draw inspiration from them in other ways. The intuition is that science does not operate in a featureless level environment, but rather responds to a rather uneven given landscape of working worlds that are the major features. And our lives, and especially our sciences, have been organised by the orientation towards working worlds. Now, examples of working worlds, first of all, the construction and maintenance of technological systems, in the sense that Thomas Hughes talks of them. So networks of humans, machines, organisations that together make up much of the sort of materiality, the technological spaces of our world. Now, they throw up different problems, and those problems are often the focus of particularly inventive or scientific activity, as Thomas Hughes tells us. Now, I think that probably the most, in the 20th century, perhaps the most dominant working world was the fourth one here, the mobilisation and maintenance of fighting forces. there's no doubt that a lot of 20th century science, if you're thinking about computer science or radio astronomy, or all kinds of physics of different kinds, of chemistry, a lot of it makes sense in relation to military systems of different kinds and their demands and their problems. Rivaling that in the 20th century was the working world of the care of the human body in sickness and in health. And I might add a fourth one, which is civil administration, and I'll give you an example of that, of how it works. Thanks. And at the end, I think I'm going to add a fifth. So this is an incredibly crude diagram, which tells us, maybe illustrates some of the processes in this. If the world of which sciences work are made up of these kinds of working worlds, what they do, there's different phases in this. First of all, from those working worlds, problems have to be articulated, a process of problematization, which is not trivial. From those problems, scientists don't work on them directly. What they work on is simplified representations built out of those problems, on which the typical work of science is the experiment, the theory, the hypothesis, hypothesization, and so on is made. And then there's a fourth phase in which those conclusions have to be fed back and turned into solutions. Now that's quite crude. So let me give you an example. The working world of civil administration, well, civil administrators often have to deal with the issue or the problem of the location and movement of people. Excuse me. It's a problem that can't be solved directly. What the approach is, or one approach, is to build a simplified representative, which is to take a census. Right? The database of census data is immense, but it is much simpler than the vastness of people and their movements. And on those census data, it's various kinds of statistical experiments and theorization can take place. And we find many kinds of these kinds of simplified representatives. So a census is one, but we could think of others. General circulation models for climate science, another good example. And let me give you some more. One of the sort of claims is that this approach obviously, I think, helps make sense of quite a lot of applied science in a fairly trivial way. But it also makes sense if we read some of our very best historians of science of some of the more, I guess you might think of being pure, the achievements of pure science. So David Kahan's An Institute for an Empire, which is a study of the Physikalische Technische the German standards laboratory, I think within it has got a very interesting story to tell about where did Max Planck get the data from of which he was trying to make sense when he offers the equations within which there are quantum terms. So what the problem there is, it comes out of the electric light industry, of which the Standards Institute is working very closely. The problem is measuring luminosity. The simplified representative in that case is simplified experimental systems of which luminosity measurement can be made. And it's making sense of the data that comes out of those systems that Planck is working with. So there we have, right at the birth of quantum theory, what might be taken as one of the very bright spots of 20th century science that might not make sense, not easily make sense on its own. If we read our good contextual history of science, then we can find a story which relates it to wider working worlds in interesting ways. One more example, if you read Peter Gallison's Einstein's Clocks, Poincaré's Maps, we find a very interesting argument about how Einstein's special relativity relates back to what he was actually doing as a patent clerk. Like it's this usual ironic story about Einstein, oh, he was a pattern class, third class, you know, wasn't that a tragedy that such a great intellect might be working in such a situation? In fact, in Gallison's account, it was precisely the right place to sit if you wanted to see all kinds of interesting technological systems and their problems, and to be thinking about them. Special relativity doesn't go back and solve the problems of coordination of clocks, and that is one of the interesting things. It doesn't, these things do not have to be turned into solutions, even if they are prompted by problems. Now, so that gives you some sense of working worlds. My contention is that that actually does make sense of quite a bit of 20th century science, including some of the more purist aspects of it. Now, how do we then think about promises? Well, one thing that this invitation started me doing, which I probably wouldn't have otherwise done, is to actually start thinking, what is a promise? And I've come up with this list of sort of features of what makes a promise. Well, a promise has to be between two entities, between two people, generally. But I've said it's a relation between two actors, because the promises made by science aren't necessarily individual to individual, even though they are between two actors. Something has to be offered, and something has to be, in theory, delivered if that promise is going to be fulfilled. There's a moral obligation to fulfill that promise. It's right to fulfill a promise. They're created by acts of will, not merely contingently. By that I mean it's you can't accidentally fulfill a promise. That's not a promise. That's just a beneficial outcome, I suppose. But you can get benefits that aren't the results of promises. It has to be it's an act of will to offer a promise and to pay it back. As JAUME told us, they have a time dimension that is crucial. A promise is never delivered instantly, is it? If I offer you a promise, I say, "Oh, here you go. I fulfilled my promise." That feels wrong. A promise has always got a gap between the offering and the delivering. And that time dimension, for a sociologist of science or historian of science, makes us think of institutions. Institutions, as Stephen Shapin told us, are things that carry values over time. Right? Promises are things that are delivered back after a period of time. Institutions, I think, are crucial for thinking about promises. Promises are voluntary. No one can make a promise. You can't be forced to make a promise, or it's a false promise if it's extorted out of you, if it's done under pressure. It has to be voluntary. But it's voluntary in this sense. You have the choice to agree to a promise. You don't have to make a promise, but you have to fulfill a promise. Let's put it that way around. Okay. So the fulfillment of the promise is less voluntary. Promises are not owed equally to everyone. There are things that we all sort of, in a sense, promise to do, like do no harm to people. But that's not really a promise. A promise is more directed towards a person or not to everyone. And that may be, but does science promise everything to everyone, or is it to certain groups or individuals? I think only when you talk about promises, when it's not owed equally to everyone, it's to a segment of a population. Promises are consequential. If you break a promise, there are consequences. But how are those consequences enforced? Promises are quite individual usually, so you think there must be some sort of personal obligation. So what is the sanctions for breaking promises, and how are they enforced? Well, it must be social. It's socially learnt, and it must be institutionally enforced. I don't know. But it's something you can ask about when you come to think about the promises of science. Finally, there's lots of other sort of similar concepts that are a bit like promises, that share some things that we may want to think about the differences here. There are contracts, there are vows, there are oaths, there are pledges, there are treaties, there are agreements. These are things that are promise-like. Maybe they are promises, maybe they're different. So it sits among a range of related concepts. I still don't know what promises are, but that is a list of sort of characteristics that if we're thinking about promises, we might want to think about some of those points. Now, how does this come back to working worlds? Well, within my sort of concept of working worlds and the science's relationship to them, well, something is certainly offered, which tends to be problems, and something can be returned, which are solutions. So there is a promissory relationship, or there's a potential of a promissory relationship. Does that make the sciences generally a promissory institution? I think not always. First of all, just because some things are offered and something delivered, that is not alone constitutive of being a promise. A promise requires an exchange between the same actors, probably, and an obligation. Now, those actors could be something as general as the public and the sciences, or the economy and the sciences, possibly. It can be more tightly or individually targeted. I think, thinking about this, I think what I can certainly say is that the extent to which the sciences are promissory has varied over time, and the expectations of that promise, relationship of promise, has been at times quite loose and at times quite tight. And I think that we are now in a period where that relationship is quite tight, because you find plenty of expectations that the research programs of the sciences have to be tied back to, for example, economic impacts of various kinds. That is an institution or a framework that the sciences have had to work in, which has had a distinctive form, at least in Britain, since I would say, early 1970s, when a much more contractual language came in for science policy. It is going to be different in different places, but it may well be the case that that is a transnational phenomenon. I'm not sure. It also depends on the sciences. Different sciences have a much more closer relationship between the sciences and their clients. And chemistry, for example, has always been much tightly bound to the demands of industry. I mean, understandably, I think, than, say, I don't know, types of physics, for example. So I think the extent to which working worlds are promissory has varied. There's something about institutionalization there, by which I mean sort of the formal way that has been bound, and also about how it's carried over time, how promises are accounted for, if you like. So I think there's something very interesting in that. I'm well aware that there's plenty that needs to be developed with the concept of working worlds. I'm in the process of trying to tear this concept apart, really, to try and criticize it and develop it further. How many are there? I've given you 4. I think there's probably more. Does it matter if there's a lot of overlap? How far back does this concept help us historiographically? Is there a working world for alchemy, for example? I'm not sure. it's not an account that you find in fairly simplistic, I suppose, history of science, the sort of timeline history of science. How are these relations, these traces of connection erased in a telling? There's a problem of where do you stop when you give accounts of histories. That means of history of science, about if you do have a certain amount of choice about when you give a historical account of what kinds of factors you stop at, and that leads to conclusions about what kinds of history you're doing. I'm not going to go into that now, but if anyone's interested, I can talk about it more, say, over coffee. Graham Gooday, a historian of science that many of you will know, did a nice review of this book when his objection was, but there are cases of entirely insulated science. His example was black hole physics. You know, what problem of the world is black hole physics trying to solve, right? So are there cases which are just absolutely insulated, they've got no relation to the working worlds, right? Now I think there's an answer to that, even in the case of black hole physics, of what, say, Oppenheimer was working on in the late 1930s and others, Wheeler and others. But it does get rather complex. And then there's a host of similar concepts that I'm interested in exploring. I think there's also things we might, talking of time and looking backwards and looking forwards, I think there's some useful conclusions or suggestions for, say, science policy. If we want to do some blue sky thinking, this is the kind of sky we always get in San Sebastian, I believe. So, for example, this is an objection that my father-in-law pointed out to me. Yes, it's a difficult relationship. He argues with me. My father-in-law said, well, he's worked in development, education, Africa, and in the Pacific for most of his career. And he's seen plenty of problems of which the sciences don't touch. I mean, the example of various kinds of diseases, third world medical problems, which, for example, the pharmaceutical companies do not address. The sciences there to address. What do you do? How do you account for where there are problems being articulated but no science? That's a tricky one. My PhD student, Matt Paskins, is an excellent PhD student, also argues with me. He's pointed out, well, perhaps there are things that have this working world relationship of problems and offering solutions, but are things that we may not want to describe as sciences. So there's a question of, there's an interesting question there. In terms of science policy, I can see a couple of suggestions. What do you do with, how can you turn it into something like a lesson that might be learned or things you might suggest? Well, one point might be offering artificial challenges, creating working world problems, creating working worlds artificially may be a solution. If you think about the space race, right? The space race was in terms of yes, you can give an account in terms of Cold War politics and so on. That obviously drives the space race. But what's interesting about it is that it was set up, the challenge to go to the moon was an entirely artificial one. There's no need to go to the moon. But having set that challenge, it generates problems. You can have artificial working worlds from which quite a lot of literal spin-off can happen. Other things don't work. Just simply setting targets for research and development spending has got no justification under this model. Just simply spending money without relationship to thinking through its relationship to working world problems, it seems to me, is going to be unproductive. Okay, I wanted to end. I want to leave good 15 minutes for questions, so I'm just going to speak for another 5 minutes. But I did want to tell you about some of my more recent research, because the 20th Century Science book really started way, way back when we were teaching in Cambridge on 20th century science, and it's, that's 10 years ago or so, probably. It came out a couple of years ago. It's been quite a long process, but it is, in a sense, old work. And I've been getting into some new projects, one of which, and these also raise questions about the promise of science. And one of the projects I've been getting into, and I'd be very interested if anyone else is working in similar areas or is interested in this, is how do you measure how rare a species is? And that's quite a crucial question because a lot turns on it. There may be legislation, for example, either international legislation about the trade of species or national legislation about the protection of certain areas, nature reserves, whatever. That all depends on whether or not you can say a species is threatened with extinction. Right? It's, if you taking the title of a recent book, we are living through the sixth extinction, a sixth massive wave of extinction of creatures, of which many creatures are threatened with extinction. But how do you know whether a species is threatened and at what and how threatened is it? Well, that has changed over time. I've got a long paper, and I'm very happy to share a long paper with anyone who's interested. But here's the short version. The short version is that there was a shift in the 1990s that happened because of an appeal to the promise of a certain kind of science. Now, before that, if you wanted to know whether a species was rare or not, you would open a book like this. This is the Red Data book. This is the first Red Data book from the 1960s. It's a compendium of rare species. If you open it up, you see something like this. Essentially, it gives you information about a rare species. This is about the thylacine, which is the marsupial tiger in Australia. This is the rusty numbat. It's another marsupial. The crucial thing here is a number down here. 1 was, and here 4. You can't see it, but believe me, those numbers are there. What those numbers simply are estimates, are judgments by experts. They think it's a level 1 rare species, 1 being the rarest. This is a level 4 species, 4 being less rare. It's a number that depends on expertise, but it's not a calculation. It's a number that is just simply an expert judgment about whether they've seen many of these recently, how well they know the area. It depends on people being there. It's very difficult to say, to give grounds for it beyond an expert believes it's true. Now, in the 1990s, let me just speed through some of this. In 1990s, they are replaced with a different kind of approach, which is a criteria for judging whether things are threatened, which depends on very careful measurement by using population biology, conservation biology. It appeals to probabilities, and it depends on calculation. Right. And what's happened here is that there was a very interesting appeal to quantitative conservation biologists for new criteria which were developed and were embedded into the new systems for deciding whether something's rare or not. Right? And it was done in the face of a lot of criticisms, that it was too expensive, that it was not objective, it couldn't count cod. Just give you one example, just because this is a local one. I don't know if anyone recognises this animal. Anyone? Anyone? This is the Pyrenean desman. It's like a river vole. You're not going to see one, but they do live around here. Okay. The problem there is, to calculate whether the desman is rare, according to the criteria that developed, you have to decide whether its range is 100 kilometres squared, let us say. But a desman lives by the sides of rivers. Now, how far along the side of a river do you include? If it's only 1 metre from the river, well, then it's a very narrow strip. But if it's 100 metres, then you get a much larger strip. Those kinds of difficulties were typical in the actual way that these calculations could be done. So there were real problems with this appeal to population biology. But, crucially, there were promises. And the promises were ones of objectivity, that a appeal to robust numbers could insulate the science from the politics, it was thought, it was hoped. Yet it could be put to political purposes. So it could insulate science from politics, but it could achieve political ends. Now what's going on there is, in the background is a lot of countries, particularly southern African countries, wanted a new way of deciding how rare the African elephant was. There are other pressures as well, but this is one of the main ones. And for them, this was a way of showing objectively that elephants were not as rare as people were saying that they were. Okay? It needed that kind of a political purchase for countries to be interested enough to back them, to use them in international governance. But it was the promise of objectivity, and the term objective comes up again and again, which was the which did that work for them. So the promise of objectivity was one of the main advantages of appealing to science at that moment for this critical problem of world conservation. And the other promise was that science, when it can be put into that kind of quantitative form where you're appealing to a rule of method rather than an expert judgment that might just be in one place at one time, is that it can travel more easily. Right? That there was a promise of broad applicability. You had a universal measure of rarity that covered all creatures and all places, in theory. The interesting thing is there's all kinds of problems. Won't go into those. I'm just showing this picture because they could put on one map, one diagram, as things as varied as cycads, corals, mammals, and birds, lobsters. The point is that it's by appealing to a method in this case, the promise was of generality and broad applicability. And just going right back to the beginning, it was this kind of case that convinced me that actually I think a fifth working world I needed to name. So we've had the construction and maintenance of technological systems, like electric light systems. We've had the care of the human body in sickness and health. Think of medical biosciences. We've had civil administration. Think of the social sciences, the census. We've had warfare in the 20th century. But I think the monitoring and maintenance of global order, if you like, this could be global order, both in the sense of sort of international conservation, but also things like world economy, measuring, maintaining, itself generates a lot of modelling and the sciences around them. Okay. And in each of those you find promises of various kinds. Okay, that's it. So I make it just gone 10 o'clock. Thank you. Thank you.
Is this working? Okay, now it is. I think at least there's a green light. Yes, sure. Anyway, so thank you, John.
We've got over 10 minutes for questions and comments, ideas, whatever you might want to say. So only make sure you have a microphone with you to do so. Yeah.
Thanks, John. I'll start with I'll ask something which is a little bit from the side, but it bothers me for quite a time. You mentioned a few examples of how what you call working worlds, in this sense, technological systems, made influence into the science, and now, of course, the difficulty I have with that is that, although in both examples that you gave us for black body radiation and for clock coordination, there is some association. It's the way that you tell the story makes it seems as though there is a real strong causal connection, while it is, if I recall correctly, Khan is very careful about it, and I think he has very good reasons. Especially if we remember, for example, that Einstein 1905 paper that shows the need for quantum hypothesis does not need any observation about any exact observation, because there are some inner theoretical contradictions. And Garlison, I think, is very evasive in all the way that he writes the book to claim and not claim the same on the same time. So what I say, what my question is, we have this problem coming, which the real problems, as much as I understand, in these cases, not in all cases, are coming from physics and from the way that people try to put it, and then of course there is no insulation. This is two different things. So. But there the problem comes, and not so much from the working worlds. Well, in other places it's different. I don't claim for generality.
No, all right. So go right back and look at a diagram like this. There's an awful lot going on up the top here, where the sciences are responding to the sciences, within which you can tell a perfectly, I think, perfectly recognizable story of development of physics, which can be quite an internalist story, right? And I'm absolutely happy with that. There is, though, a relationship between the wider world that we need to sort of identify what that might be. Okay? And I think the case is that even though there's a lot of the development of the sciences is in response, it is in the immediate response to what other scientists are saying. So in this case, the development of quantum mechanics is essentially, the next paper on quantum mechanics is mostly a comment on the last paper on quantum mechanics, right? There is nevertheless a connection, a golden thread that goes through to working world issues. It's not determinative. It's not determining. Nor is it, but it is causal in a sense. Plus, I think within the physics, the physics that's going on has already been developed in response to older working worlds. If you go back to what Maxwell is saying in the mid-19th century about the relationship between his theorizations of electromagnetism and the work of the telegraph engineers, right? He is quite open, unexpectedly open, given that he's a Cavendish professor. He's quite open about the connections between the working worlds of getting telegraphs to work and the development of electromagnetic theory. Now all I'm saying there, I think, is that not only is there a lot going on up here, which can be quite self-contained, but not entirely self-contained, it might be just simply the case that it's dealing with the sciences that are developed out of older periods, which does often have a connection between working worlds. For example, electromagnetism and getting telegraph to work. Okay. You can tell more about some 19th century physics of William Thomson and whatever, but I think that case can be made. Okay. But I'm not, you know, I think this is a kind of world in which the externalists and the internalists can live happily, right? It can contain both those kinds of accounts of the sciences, and I'm happy with that. That's okay. So, does that help at all?
Yeah, I think it helps. Perhaps the problem I have is that it's like the way that you presented it seems that the problems come only from the working worlds, and the problems have quite a few places to come from, and the working worlds is important one of them.
Yeah, no, absolutely. I think, and in going on up here, there are things that are set as problems by the sciences that come from the sciences. But the broader framework is a working world relationship to the world. It's just simply that they're not working in a flat landscape. It's an uneven landscape of which there are problems.
Okay, so if we have in the 5 remaining minutes time for Haro, Maria, and Thomas.
Okay, thank you very much. Well, it's a very inspiring and full presentation. So I think it's an excellent starting point for the workshop. And I'm afraid I will go along with the former question, also with your father-in-law, that it doesn't necessarily start with problems. I take a small detour to that. So one thing is that it seems that you are flirting with social theory. So, and maybe you don't like that term because, but flirtation is at one hand it's interesting, flirtation, but it's also, it raises the question, how serious are you? Because there are all kinds of social theories that address this, like social worlds theory and networks or institutions, and you referred to that. And also in more political science, so the role of experts, and I was especially thinking about the multiple streams theories and garbage can theory. Maybe you've heard about that. So in garbage can theory, you have it's an understanding of policies and political worlds. There are people preparing problems, and there are people who are preparing solutions all the time, and at some point they come together, that you have windows of opportunities for that. So there are all kinds of threats that you could, so my question is, how serious are you with doing that? And with regards to your grandfather, I think I will come to that in my talk, that it doesn't start with problems but with promises. But my basic question is, how serious are you, or is it really, so is it on your agenda, or do you think, well, there are some interesting things here, but it's the historical work is more important here?
Yeah, what I've done, I think, is clear away a lot of things you could talk about in order to identify one thing, which is what kind of relationship the sciences have to our wider world, right? And to do that with clarity, you have to not talk about quite a lot of other things. When I'm coming back to it, though, I want to do it seriously in your terms, and to try and say what is its relation to the other terms we find in the social sciences and social theory. I mean, things like different kinds of social worlds, for example. Your specific example of the garbage can theory, though, I think supports exactly this kind of model, that people that the relationship is quite often to offer problems and come back with solutions. In the garbage can model, when the new crisis happens, you haven't got time to do new research, so you look in the garbage can and find the solution that you have to hand. I think, if anything, it tells us that this model of offering, of thinking in terms of problems and solutions is precisely what's going on there, and it can be criticised because in moments of crisis, as we know, the BSE crisis in Britain was a good example of this, of finding the solution that someone's already worked out. Right? It short circuits this model of perhaps how it should work, but it does tell us that is how people think and behave in institutions of policy making. So I think it can be brought in actually as a illustration.
You gave us a lot to think about, so thanks a lot. I also want to focus on the diagram because I think this is the more exciting part, let's say, of your talk. This is the main part of your talk. And I think the diagram doesn't make justice to the main concept that you present, the working worlds. When I saw it, it reminded me the way I teach the logical positivists sometimes to students, especially the last part, and all this close relationship between the experiment and the theory. And I think there is a huge leap between the working worlds, the problems, and the simplified versions of the problems, because there you have huge other things that come into this. Who decides what the problem is, how you simplify the problem, who simplifies the problem. So all this is out of the diagram. So
it may be out of the diagram, but they're precisely the right questions to ask, right? So not every problem gets articulated. Who is warranted with saying something is a problem and not a problem, right? What problems can you build simplified representations of? Might be not all of them. Which ones do you choose? Who gets to articulate? What role does the public play? They're all precisely the questions that I think you can ask once you have this, or you can put into a picture like this, right?
This is why I'm saying that maybe the problem is with the diagram. I haven't read the book where you develop this concept, but the diagram, although you make very obvious the experiment and the theory, you expect the reader, your audience, to make all the other questions, like all the stuff that you just said. There is no way to show that this is already there. You said that this diagram can make happy both externalists and internalists, and I don't think you can really find a diagram or a concept or a way of thinking that makes both ends of the spectrum happy. So I think you have an issue.
I know,
there.
it's provocative. You're absolutely right, of course.
And a very small comment about the end, maybe I didn't understood it. You speak about the promise of objectivity at the end. Maybe we should discuss this more, but I think you cannot promise objectivity. Either you have objectivity or you don't, because if you promise objectivity, then you are not persuasive anymore. You are not objective anymore. You
you are
objective
I absolutely
or you
think
are
that they were
not.
promising objectivity, and the responses that they got back shows that the objectivity wasn't a given. It doesn't simply come from applying the method. And I think not only in the specific method that they were proposing, but any similar kind of method could be objected to in similar kinds of ways, because there are always assumptions. There are no rules about how you apply rules. So in this case, when you've got a method that tells you this is how you're going to generate the number, there are still uncertainties about the interpretations of many of those terms. So whilst they can promise objectivity, it's not something that is necessarily delivered. And the criticisms that came back, I think, basically illustrate that point. People say, well, you can't promise that, or you'd have to have you'd have to develop in this different kind of way, let us say, or that it was going to be too expensive. So it's, I was agreeing with you entirely in everything you said up until that last point. I think when they said that this would deliver objectivity, I think it was a kind of promise. You can't promise something that is certain, right? That's not a promise. So it has to be something that needs extra work to be delivered back. I mean, there's no point in me promising that you exist, because you exist. It's not something that I can do anything about. A promise has to be something that extra work has to be done. That means it can be fulfilled, right? I'm groping towards something that is about the nature of promising there, that I think is important.
Whether Maria was on the lines of how can you promise objectivity if objectivity itself is a changeable notion.
This is why I said you gave a lot to think about, and I think it.
Anyway,
Sorry, yes. But on the first point, every point of these generates questions: who, what, where, how. Yeah. Sorry.
Okay, I'd like to better understand your key concept of working worlds. And you emphasized promises can be a key component of working worlds, but then from a logical point of view, one may wonder whether promises always are key concepts of working worlds, and whether there are working worlds without promises, and this would be rather special working worlds. But to understand this concept, it would be useful to have an example of this rather strange working world that does not
Doesn't
contain
have a promise. Yeah.
a promise.
The nearest I could think of was whether if this, maybe there's a working world problem, there may be a science is working on those problems, right? But the solution might come back from another different sort of science, right? Which hadn't been thinking about that being a problem that they were specifically working on. So while something is offered, a problem, something is delivered back from the sciences very generally, does that make a promise? Not necessarily. That's why I was saying that does a promise have to be between two specific actors? Or can the promise be fulfilled by someone else doing an action? And does that count? That's the kind of
This
science
points
without
to
promise.
The problem,
Yeah.
that you compared promises of science rather closely to individual promises.
Yes.
And I wonder whether this is really the case, and perhaps it could be that the concept of promise here is used, so to
Yes.
speak, in a metaphorical sense. That is to say, the nature of the scientific promises is quite different than between the one of individual promises. For instance, what are the sanctions if I don't keep my promise, or if science doesn't keep its or her promise?
Yeah. Briefly, I think that's the right question to ask, because I think maybe when we talk about promises within the sciences more generally, we are talking about a different kind of thing than an individual promise. But that is how that's where the word comes from, so maybe we should think carefully about whether it is a word that applies.
Good, thank you, John. Let's
very much.
thank him again for
Cheers.